Hi, class. Hope you're having a great semester so far. So far, you're doing great. Like your scores are really good, and yeah, I'm really happy with the class, and I hope you're having a great summer. So I wanted to do intro video for this module 3 that has to do with the normal distribution. And I'm just going to talk about it a little bit and have an example or two here. So let's talk about it. Like I guess the first thing is, do you remember what a distribution is? It just this range here tells you the values of the data, and the height is how often does it occur, or what's the probability, the likelihood that it happens. So if I gave you all an oral exam and had you come in and tell me what is a normal distribution, what would you say? If you told me something like, oh, Dr. Klein, it's a bell-shaped distribution, meaning that most of the data is kind of clustered around the mean, and as I get away from the mean, there's less data. That would be like an A+ if you got that. If someone says that data is distributed normally, it means that most of the data is around the mean, and as you get away from the mean, it kind of tapers off, right? It tapers off, right? So, and it has this bell-shaped. And why is it so important? Well, there's multiple reasons, but let me just say that, before there was a name for it, scientists started taking data, and maybe I'll do this. They started taking data, and they noticed that there were a lot of different types of data that kind of fit that description. Like, they looked at, let's say, IQ scores. They put it on a frequency distribution, and they're like, wow, most people are in the average, and then as you get higher IQs, there's less and less people, and then low, and it looks like it's bell-shaped. And then they started measuring grasshopper lengths, and they said, ooh, like most of the grasshoppers are in the middle, and then some of them are bigger and some are shorter, and they have this weird, hey, look, it looks just like the IQ curve. And then, the iris petal of, the petal of a flower, that like most of them were the average. So anyway, what I'm trying to say with that is this data set, this distribution was showing up all over the place, and it made scientists want to look at it more closely until Gauss actually came up with an equation for it, and it has these interesting properties, and we found out that it follows the empirical rule. How interesting is that? So the normal data set happens all the time. If I got all of you together and measured your heights, there would probably be a average height and then a bell shape around that. Like, as there were taller students, there were fewer, and the same on the shorter end, and it would stack them up. If I counted them and made a little graph, it would look bell-shaped. So it happens all over in nature, and because of that, it became interesting to scientists. And then they started making all kinds of interesting observations and tests, and it's kind of the foundation of a lot of basic statistics. So anyway, I wanted to just tell you that. That's what we're doing. Let's go back here. Now, of course, at the end of the day, you need to know how to do your problems. So what I want to show you here is I don't want to use tables. I just don't see the point. I think we have calculators, we have computers that can find answers for us. I want you to know what the answers mean and not worried about the tables. And so look, if you go to StatCrunch, I wonder if I have that here. StatCrunch, let's see this. So on chapters 5 homework, on I guess it's module 3, 2, 3, and 4, I think that's right. you're going to use this stat, calculator, normal all day long. That's what you're going to do. Stat, calculator, normal. All right? And you're going to get this little tool here. And look, there's 1, 2, 3, 4, 5 boxes. If you know how to use this little tool, you're going to ace this. And I'm going to tell you how to do it right now. So, look, the mean and standard deviation must be given in the problem. All right? Unless they give you a data set where you have to use StatCrunch itself to find out the mean and standard deviation. It's going to be stated in the problem. So those two, out of the 5, they're going to give you 4. And those two are always given. I hope you can see this. And then what's the next? Okay, so this is the greater than less than is telling you the shaded region. Is it to the left of this boundary? This point is the boundary. Like, let's say I put, I don't know, let's say I put 1.5 in there. So this means to the left of 1.5. This box is the boundary, so there's the boundary. And this has 3 meanings, possibilities, all right? It means the area of this shaded region, all right? For a probability distribution, the area under the entire curve is 1. So the area of the shaded region, or in this case to the left of 1.5, is 0.93, all right? 0.93. That is the area. It's also the percentage of the data. So that's going to be 93.31 whatever. 93% of the data is here, and that means, what is it, like 6-something% is here if I went the other way. All right, this is 6% of the data is to the right of that boundary. See how that works? All right, so what is this box here? This box is the area of the shaded region, or it's the percentage of the data, or last one, number 3, is it's the probability that if I took a random data point, it would be in the shaded region. So it could mean any of those 3 things. And depending on the problem, you'll have to figure out which one of these boxes, 4 out of the 5, they're going to give you all the information. And you'll have to, and then you hit compute and you get the right answer, right? So let's just do a sample here. Oh, no. Hang on just a second here. Okay, so I hope this is working now. Anyway, let's do some homework problems here. All right, oops, oh no. Let's see if I can grab that over here, okay. All right, sorry about the technical difficulties here. Let's do this problem. All right, it says, find the indicated probability, find the indicated probability using the standard normal distribution. All right, so let's figure out which one of these boxes they've given us, all right? So the first thing is the mean and standard deviation. If it says standard normal distribution, like it does here, standard normal, if it says the word standard, or it has a Z, then you automatically are going to put 0 and 1 in those 2 things. If it doesn't say standard and it says X, then you're going to type in the numbers that they have. So we got 2 out of the 5 done. All right. Now we've got 3 left, and the greater than or less than, you can just see right in the problem, that's greater than. So we're going to change that to greater than, all right, greater than. And it means the area to the right, all right. And then the boundary is 1.62, so greater than 1.62. And so we've got 4 out of the 5 boxes, and you hit compute. And the answer is 0.0526, which you could just take that and copy and paste it right into your answer and get that right, okay? So anyway, since it says standard normal, We know the mean is 0, standard deviation is 1, and then it's a greater than, and there's the boundary. All right, so let's go to the next one. You don't have to worry about these tables. I prefer you don't use those. Okay, so this one, look, it has an X, it doesn't have a Z. Let's see if I can pull that back up. Doesn't have a Z, so we've got to read the mean and standard deviation right out of the problem, 86 and 4. So 86 and 4. And 4 here. All right, then this is a between problem. It says, you know, find, what is it? Find the indicated probability, all right? So you know that the probability is in this last box here, and that's what we're asking to find, all right? So we don't know that. We have to find it, and we need a between. So click on the between here. Did you see that? If you click this between, you get 2 more boxes. So we're going to put 73 and 83 in there. All right, compute, and there's our answer. So in this one, we didn't have a standard, didn't say standard, and it gave us an X. So we put in our mean and standard deviation, and then we figured out what other information they gave us and which box they were looking for. Find the indicated z-score in the graph to the right. All right, so it's in this one, it's looking for the boundary, and it's actually giving us the area of the shaded region. All right, so let's see what we can do here. Can I put this over here? All right, so that's the shaded region is to the left, so we've got to make sure we're going to the left over here. It's z, so we're going to put a 0 and a 1 because it's standard normal. It probably says that. Well, it doesn't say that in the problem, but it does say z. All right, z. And then it says find the z-score, which is the boundary, which is right here. So we don't know what that is, but it does give us the area. So we know we have this 0.2358, and we do our compute, and there it is right here, minus 0.719, I guess 8, or minus 0.72. Right, it said round to 2 decimal places, so we get minus 0.72. Anyway, I do think that these problems are on the easier side, and if you kind of understand how you use that StatCrunch and the meaning of each one of those boxes, you're not going to have any trouble with this. So anyway, that's it. I hope that helped you out. Let me know if you need something.